Welcome back, Generals, to another Let's Fix Generals 0 hour to make the best game ever. Good, let's see what we can do. Looks like the only thing we do is code reviews. Because everyone is spamming new ones. So, review approved. What do we have? We have... What do we have here? Extract Scorch rendering. Is this now ready to merge? No. This one, I think we can merge, yeah. This one is simply enough. If the upper font point size limit. Done. Good. So that is sorted. Yep. Good. Then I think we had a comment here. Was it replicated in generals? Yes. Let's put a checkbox here. Okay, so. So this one is resolved. Okay, so there's one more comment here. So, Baptista says that this is not a hallucination, but also not a blocker. The difference isn't noticeable. Size rates multiplied by pow delta timescale is rate independent, but size plus size rate is not. Accumulated size over one logic frame. A proposal. Okay, so there is a proposal here. Then how about... Are we on this branch? No. There we go. Check out. So we go to particle sys. We can also disable generals from our CMake. Yeah. RTS. Oh boy. RTS. Generals generate. This gives exactly 1 at TS 105 0.251 for delta 05 93 99 10. It is identical to the current behavior. Okay, let's test that if that fixes anything. So particle sys. Update. Okay. Okay, things are slow right now again. under. In which change do we add those new functions? Why are they not here? Oh, they're probably further down, aren't they? Here. Ah. How about we take these functions and we put them to the top. Okay. Okay. So he wants us to add this function, which is called scale rate damping, which looks similar to this, but not quite. Decay. What is it doing? So we also have a decay here, and then we put that here, and so this function does basically do the same, except it doesn't multiply. It's damping here. Okay, that's fine. We just copy pasta it for now. And then he wants us to change this here. Okay, let's see what happens. So angle Z. Here, this one, yeah? Let's see. So instead of these guys, we do this, yeah? Angular damping. Okay. And then these guys. And then this as well, yeah? Angular damping. Okay, so we have that, and then we also want angular damping. Yeah, and then this, yeah. Size plus equal that. Okay, let's see. This one, yeah? Good, then let's test that. If that does anything good or not. Let's see. Good. Then how about we do author Cabal. Let's see what he has currently opened. A lot, but only 4 up here. So this one I think is still work in progress. Yep. What do we have here? Yeah, then we still have an open discussion. Okay. And here we have, should be considered. I think that works changed. Okay, so he did some change, right? To do simplify the code by moving the second branch up. Simplify. Let's try to move this checked first. Uh-huh. Mm-hmm. 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 If not, it's trying to move. Mm-hmm. Mm-hmm. Okay. Guess we can test it again. Let me go here. Kabbalah. Mm-hmm. Mm-hmm. So let's give that a spin. And that didn't work. Okay, great. Let's try that again. So the question is whether the particles look correct now or not. Oof. Well, the resolution is a bit large, isn't it? Yeah. The question is, can we click here? No. Oh boy. Okay, now we are trapped. We need to open the options ini. So that is 1600 by 1200. Good. Then let's see what this gives. So I would say we start with our familiar China particles, which are here, our favorite particles. So let's see. So here they look normal. Then let's do a slow down. The blob, does that have the right size? It looks a bit large. Maybe. Maybe it's fine. Okay, it's really hard to tell whether this is correct or not. I think what we need to do is load up the original game. Do we still have our test particle? Data ini particle decoupling test. I think it was this one. Let me take that, put it in here. Then we launch original generals. Then we launch this one. What happened here? Why were there particles there? Good. So here this one has a modified particle for testing. Yeah. So load game and use a here. So then let's zoom in on this guy. Then we do a slow motion. Okay, let's put these here side by side, like so. Okay, then we need to pause it, I think, like so maybe. How do we do it? Looks very similar, I would say. Yeah. I don't see a discrepancy. Okay, what about this blob here? I remember we had troubles with this guy in the past. Looks about right. Yeah, okay, I don't see any discrepancy there. What about this one? So here we have some nice fire. Looks the same. What does it not? Yeah, it looks the same to me, but it already looked the same before. So I don't know. Sometimes this explosion effect comes up here and sometimes not. It's interesting. Yeah, so I don't see any visual discrepancy. It looks the same. Yeah. Okay, let's try faster. Maybe we have to test with more extreme limits. Maybe we have to test with more extreme limits here. Previous. 5. So 1. Erase revenge decomp. What is this? Well, that would take a while. Good. Then let's test that again with min FPS1. Load. There we go. Then we do 1. Oh, that didn't work. There we go. Okay, so that is pretty much slow motion. It looks very smooth. So this is now 1 logic frame per second. So very smooth particles. Okay, let's compare that with this one. We stopped shooting. Okay, so this one, let's take a break here. Let's try to compare it with this. Like this, maybe. Ah. Looks identical to me. Yeah. So now the question is, why is this correct then? Let me see. Let's go back to particle sys. So we added this one here, angular rate z times scale rate damping. but why? Why do we need damping? This one is not damping. This one is just time scaling. I don't understand. Hmm. 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 Damping, time scale. Hmm. Hmm. Okay, how about we compare? So what we can say here is that this looks pretty much the same, right? So let's do. Let's do. Define before one. Then we say if before, else, and if. Before, else, and if. There we go. Okay. So then let's test the before. So what do we do if both look okay? What do we do then? What we can say is that just a simple multiplication here is cheaper than this power function inside of this. Yeah. So this one is cheaper than this, which would be better, but we are more concerned about correctness. So no matter how expensive it is, we probably take the correct one. But if they are the same, then what do we do? So we have this guy. Then let's go here. Then we do slow motion. Then we try to catch the right moment. Maybe there. I think there. So how does this compare? Is the camera zoom level correct? Yeah, the camera zoom is correct. So I think the perspective is pretty much the same. Let's move this closer. I really have to get our spy glasses here. It looks like this here is a bit larger. It looks so similar. I can't tell difference here. It looks like this is a bit larger, and so is this. How can we prove? How can we prove that this is identical or not? I don't know. It looks so similar. I can't tell. Man. I can't tell. So what do we do? Try to align them exactly the same. Should be about the same. Okay, so this looks like I'm looking at this edge here, like how far they are from each other, and looks like they are about the same distance here. So I assume that they are now at the same stage. To me, it looks... I tested your suggestion and the status quo, and both look fine. But we're only really looking at... We're not really looking at angle Z, only at size, right? What's going on? Yeah. The rate independent, but this is not. Scale rate damping, what does it do? We don't see a difference. Maybe we are looking at the wrong particle. Let me... Do we remember what particle this was that we touched for testing? Data, any particle system. Oof. I don't know. I think it's something about explosion or so. I don't know. System. Faction small. Okay, so way too many particles here. Okay, but this one is 0. Yeah, so if it's paused, then nothing happens. Let's say it is not paused, then what happens? So time scale is 0.33. Claude Noy, I think. No, what is his name? Oh, Claude Noy. There's a J. Let's take a look. The dummy manager overrides init and reset with no ops, so particle system templates never load. Game logic reads those pointers. Skips scheduling target block. Targeting block when the template is null. Templates load in both modes. Okay, so this already rings alarm bells because it was actually intentional that the dummy doesn't create the system. So what is this? Getting target position. Oh, I see. Gatling strafe FX particle system. Um, do we decouple this then? So the problem here is that this is decoupled. This is coupled with the particle system. So how do we decouple that? So this one says particle system templates in headless. So I'm trying to understand right now what we need to do. But to me, right now, this looks suspiciously. It looks suspicious because this was very intentional that we said on retake compatible CSC, we allow to create the particles and otherwise not. So I think what should happen is this one should do, where's TMP going? What's going on with the indentation here? We did this intentionally. We do not want particles to be created unless it needs to be retake compatible, unless it compiles with retail compatible CSC. Do not want particles to be created because of the bugs. The correct fix is if retail compatible CSC, do this, else do that. Oh, am I missing something here? type Gatling here. I didn't mean to do that. Oh, right. Yeah, so originally it would check if, but TMP and then test it later here. Let me search for. So there were some other places where we fixed that same issue. Can't remember where it was. EMP update or so. Great particle system. There are not many of them. I think it was EMP update. Yeah. Here we had this thing. TMP. So the system is not decoupled from the logic CRC. Or not. Okay, let's just do we already fixed 3 other places where particles were coupled to logic. If you can find them by searching for this. Please try to fix the coupling in the particle logic coupling in, what was it? Battleship Spectagon ship. Mm-hmm. Instead of creating particle templates again. Mm-hmm. Mm-hmm. Yeah. Mm-hmm. What is this? CSC debug log no counter. What? Exists but has no macro web wrapper. Missing update to detonate uses to record the weapons, then detonate flag, the flagged sites. Blah blah, which moves the module to a different frame. Hmm. No counter. No counter. Weapon input. Damn, detonate decides whether the projectile dies here or a frame later. Record it. Die on detonate the sides. Hmm. Hmm. Lock. Okay, I don't understand this. So it. Hmm, it cannot be used. Detonate uses it to record the weapons die on detonate flag. Hmm. Die on detonate flag. The flag decides whether the projectile dies. Two clients that disagree on it desync at that frame, and nothing in the CSC dump pointed at that flag. Okay, this one looks... Yeah. Yeah, I think this doesn't belong here. I don't know why he did open this change here. Yeah, I think this is a bad change here. I agree with we do some hacks. Do some hacks, but not these hacks. Do some hacks for UI, but not these hacks for gameplay bugs. We will fix them in ini. Not these kind of hacks for gameplay bugs. Yeah, I don't know. Was this needed for this, or was this needed for cross-play compatibility or not? Skips. Cross-platform run only proves both sides computed the same thing, not the right thing. A cross-platform run only proves both sides computed the same thing, but not the right thing. This matters. The client used for cross-platform deployment and testing forces the same flag. Ah. I think key is to understand why. Okay, so this is an attempt because apparently without this fix, it will mismatch on crossplay. Okay, so this changes situation. Then, but is that because what is this? Die on detonate. Die on detonate. Die on detonate. So it is default initialized to false. Great. Forcing missile calls on die. Okay, I still don't understand. Let's read that carefully. So, has no missile in the ini. Yes. This returns false and detonates skips attempt damage. Yes. That runs a projectile's die module. Yes. The second explosion never happens when the target is a structure. Okay, but that's fine. The fix belongs in the game data. Yes, which does not live in this repository. Yes. So the flag is forced for that weapon in new weapon template behind this macro retail builds keep the old behavior either way. Why? So the question is why? I defaulted the toggle to 0, so the fix is active in toggle to 0, so the fix is active in non-retail builds. Happy to flip it to 1. Okay. On a general engine fix, instead, missile calls on die is opt-in and most weapons chip without it. Calling attempt damage for every detonating projectile would fire die modules across the whole arsenal. Extra FX spawns shifting every following object ID. Okay, project what? Spawns shifting every following object ID, keeping projectiles alive. Long-standing behavior a lot of content relies on, and no CI covers it. The retail replay job builds with that and would not even compile the branch. While the cross-platform run only proves both sides computed the same thing, not the right thing. Okay, so I don't understand what this means. This block here is very difficult to understand. For me at least. Preserve missing Aurora second explosion. The retail replay job builds with retail compatible CSC and would not even compile the branch. While cross-platform run only proves both sides computed the same thing. Okay, I don't understand. I tried to understand what the problem is from the description. What the root problem is from the description. Let's just say I do not understand what the root problem is from the given description. My impression right now is if mission calls and die is not called, then something else happens. Ship wizard. Let's opt in. Yes, what is it, and can we fix it? Okay. Yeah, I think that needs a bit more information. Die on detonate. This is detonate. Detonate. It decides whether the projectile dies here or a frame later in do kill self state. Different frame. Lock knockout. Okay, I right now I don't understand. What problem does this solve? Detonate. There are probably millions of variables that, if mismatched, the game desyncs. Why does this flag specifically need this lock? How does it happen? And can we just fix the issue and make the lock not needed? Yeah, so I'm a bit surprised. So he added this lock, but why? There are not many of them. I think the my understanding is that adding more locks will grow the CSC lock even larger. That already is. Okay. So those are my current thoughts. I hope that makes sense. Okay, cool. So where were we? Where were we? We did something else before. Right, we were looking at particles. Yeah. What do we do now with this particle thing? I don't know. What's the time? Yeah, I don't know. It's an interesting question. Why can't we see any difference between these things? Oh, we forgot to uncomment this one here. The rotation. Yeah. Let's put a let's do a what type is this? Real. Let's do a real dummy size equals, let's do here size, let's do real dummy size. Okay, then let's get a look at this guy. Let's call it size copy. Yeah. Size copy. Then we put it here. M size. Then here we do this, and we do this, and then here we do that. Okay. So we have a size and a size copy. Yeah, and we maintain them at the same time. Okay. Then here we make also size copy, the same shit. Everything the same. Yeah. Here, size copy. Here. And that's it. That's it. Okay, so now we have a perfect copy of the shit. Then we stop this. And then we compare in debugger the size and the size copy, how they diverge. And what that actually means. Maybe this gives us a better clue of what is happening. Or if the value... We see if the value is different, or it's just marginally different, or it's not different. Then we can maybe think about what that means. So, oh, please load. Well, the only, yeah, it's okay. Use a, here. Okay, then let's put a breakpoint here. Let's see what's going on. So we have a size and a size copy, and they are exactly the same because the time scale is 1 and that's expected. Okay, then let's decrease the logic scale to 1. Yeah. So what do we have? So here we have a 3.077 and 3.02. This one is, so they're up to the second digit behind the comma they're different. Okay, so here we have a bit larger difference. Well, it's below 1, below 0.1. Yeah. So it's very small differences. But there are differences, but very small. Yeah. Scale. Yeah, so the differences are very, very tiny. There are differences, but nothing that would be visible to the user, right? Let me open them in a watch. That's a bit easier. Okay. Yeah, so as you can see, the values very, very close. Do we have particle info size? So this is the starting size, is that right? Let's do. How about we had another one? Real size start. And then here we do 0. And then here info size. So that's what it started with, yeah. Then here we do info.mstar, this info.msize. Yeah. Okay, let's test that. So then let's add size start here as well. Okay. Okay, now size and size copy look exactly the same. Because we are at timescale 1. So let's do that. Okay, let's do that. Let's increase the render FPS. Okay. Then let's take a look at this. Okay, so here we have a difference of about 0.1. So the question now is which one is correct then? Is one correct or the other? Here we have a bit more than 0.1. Yeah. Okay, so how do we know which one is correct then? Size rate damping. Size decay. But the size rate already has this decay. Why does this one need decay as well then? I looked at a few samples in the debugger. I did a comparison by looking at a few values in the debugger with direct comparison of the two different calculations, and the difference is just, I think we can, it's probably like, it's just like 1%, 2% or so, right? Yeah. which explains the unobservable Hmm. Hmm. At a time scale of 0.033, right? 0.011. Extreme. Okay, so I wonder if this is just like a product of rounding error, or I don't know. I don't understand. What should I do with this information now? Scale rate damping. Time scale decay. Hmm. It seems unnecessary. Seems like unnecessary complication of the mirror. Hmm. Rate independent is not. Um, I'm still not sure. Right. Angular decay. Rate. Hmm. 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 Okay, so it's completely unclear to me what the right calculation there is. Yeah. How about we ask... The thing is, the dampening we already take care of here. Here, scale damping. So the size rate damping, that is already taken care of. Yeah. And the same for this angular damping, it's also taken care of. More decaying. Decays. Yeah, I don't understand. I also don't understand the extreme discrepancy here that this claims. So I'm still not convinced that this is not a hallucination. It could be that the bot here is bullshitting us because it wants something to be done in a way that it thinks is right. But I also don't know better. But my observation so far is that this shit is not necessary. But I don't know. It's hard to wrap the head around how this thing works. Yeah. Hmm. 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 I'm inclined to not make any further changes here. It would be nice to prove it by observing in the game, but I don't know how we can get it so accurate. Hmm. Hmm. I don't know. But I think I will take a break here. Maybe go for a quick run before the sunset, which is right about now. But it's still warm outside. Very warm. Okay. Yeah, I don't know what to do with the particle here. This looks as if it's onto something, but I also don't know if it's right or wrong. There's no observable evidence that this is right, but I also can't say it's wrong. So it's a dilemma. It's a dilemma, yeah. Let's do the following. Let's let's remove all of this. Let's open ChatGPT. Copy all this. The following code attempts to make the particle draw step, frame rates independent, step draw independent of a fixed 30 FPS tick by supplying the timescale supplying a timescale value which tells how fast it should run, depending on the update rate of the render updates, and that's fixed 30 FPS tick. Is this correct, or is there a math error or inaccuracy? Let's see what it says. Overall, the math is surprisingly good. The key function is exactly the correct way. The more interesting part is this, because that's where people often make mistakes. Uses actually the closest form solution for repeatedly applying this. Damping, blah, 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 blah. velocity integration, which is this repeated n times. Jesus Christ, your code computes this identical, so the math is exactly right. The main approximation, the bigger issue is actually here. If you're using the final velocity to integrate the position, the original fixed step system effectively does. If you execute that twice, the position advance using intermediate velocities, not just the final one. Frame independent version instead computes. So those are not mathematically equivalent. For small time steps, the error is tiny. For larger time scale, the particle will drift too far because you're effectively assuming the velocity was equal to its final value. We currently can't set timescale to be larger than 1, so we can't test this. Only for sufficiently small time steps. For render frame rates like 30 to 240 timescale, roughly that, the error is generally very small. For long frames, timescale, it becomes increasingly noticeable. Still approximations. Integrating the continuously changing rate over the interval. Those integrations would also need closed form geometric series formulas. Can you show an example? Example for it? Yes. I want to see it in code. Damping, scale, velocity, position. Write the function with how you think it is correct. Yeah. Scale damping. Oh boy. Keep the particle simulation at 30 Hertz. Make draw only interpolate between the previous and current particle state. Interpolate. Exact reproduction. No geometric series math. Deterministic particles. Simpler code. No edge cases. Interpolate. Interpolate. Oh boy. Interpolates between the previous and current particle state. Interpolate. Between the previous and current. But then they lag behind. Okay, I will take a break here. I wish you a great day or night. Until next time. Goodbye.